Hello class. So today we're gonna do some review, some factoring time. I know it's been a while since you've probably heard that, but let's refresh some of your memories on factoring. So let's start with something pretty easy, but if it's okay if you don't remember it, but let's try to factor x squared plus 3x minus 4 when a is equal to 1. What I mean by that is, so do you remember the ax squared plus bx plus c? A is the leading coefficient. Leading coefficient meaning the coefficient with the highest degree, which is 2 in a quadratic for a function. So how I would like to start it is, let's write the equation down again. X squared plus 3x minus 4. I know that some people like to show Xbox or use that, and some people have other means of factoring, but I'm gonna show you how I like factoring. So since this is 1, we don't have to care too much about it. I'll show you an example of when it's not 1, but for now let's just work with that. So I'll try to find all multiples of 4. So we have 1 times 4 and 2 times 2. And since a is 1, all we got to do is find these two. Since it's a negative, it will be 1 is negative, 1 is positive. We got to see which one will add or subtract to make b, which is 3. So I know we're looking for 3. So 2 and 2 adding would be 4. Even if this is negative 2 plus 2, that'll be 0. That wouldn't work. So let's see. I know 3 is a positive. So I look at these two, and the bigger number should be the positive, and then the smaller number should be negative. So negative 1 plus 4 should give us positive 3. Once I get that, I just set up. So we get 2. And then since a was 1, we know that it'll just be x. Remember, the 1 is in front of the variable, which is 1x, but we don't have to write that. And now I said that it would be minus 1 plus 4. Like I said, this is a method that I've mastered. You could use method that you like, but this is something that I like because it's faster to me, and we should be doing factoring a lot faster. And just to check, negative 1 times x is negative 1, x times 4 is 4x, 4x minus x is 3x still. So that meets the purpose. Negative 1 times 4 is negative 4, x times x is x squared. So that checks out for us. And that's the first method of factoring, which is factoring by the quadratics, using that method. And now let's move on to when it's a little more complicated, when a is not equal to 1 and has a value. So first off, I would like to look at b, which is right here. And then I know that I have to have values that would create that. So I'm like, okay, a little more complicated. So I know it's 163. There's no 2. There is a 3 though. 3 and 21. And then there is 7 and 9. Is there more? Let me check. That's all the possible stuff that would multiply to create 63. So it'll be 1 times 63, 3 times 21, and 7 times 9. Those are in the factors. Like I said, once you do this more, it'll probably come faster. And this one is 1 times 4 and 2 times 2. We see that b was negative. Oops, sorry, I didn't show that. So I would like to put negative on everything. Okay. This one's a little more complicated. It'll probably take a little more time to learn this one using this method. But for sure, I would just check 4 times all these numbers. 4 times -1 would be -4, but that would be too big because 63 or -63 minus 4 would be -67, and 4 times 63 is way too big of a number, so no. 4 times 3 is -12. -12 minus 21 is -33. That's not close. That's really close, but not close enough. And 4 times -7 would be 28. -28 minus 9, that would be too much for that. So I know this one doesn't work. Now let's do 2's. 2 times -1 would be -2. That would be -65. No. 2 times -3 would be -6. And then -2 times 21 would be too big, so we know that doesn't work. So these doesn't work. Does it really fit in? Now we check the last thing. 2 times 2, -14. 2 times 9 is -18. Put those together and that'll be -32. Oh, we're like, okay, we got it. Right there. So now I have my values that I want. I'm like, okay, yes, that works. Like I said, this is tricks that will help you get faster. You just have to be fast with your factors, like when you're factoring the multiples and knowing what adds into what really fast. Don't expect you to be super fast like me right now, but one day you'll get there. Don't worry. So we know 2 and 2 are the one with the x, and I said they both have to be negative. So we're like, okay. So I'll put -7 and 9. And you know, like I said, we could check it out again. 2x times 2x is 4x. 2 minus times -9 is -18. Minus 14 is 32. And then -7 times -9 is positive 63. I know that one's a little more complicated, but like I said, this is just memory. Whatever method you like or used before, you can use this, but this is just something I like using. Now, let's move on to the difference of squares. This is another way of, you know, factoring. This one's a lot simpler, but you just have to pay attention. So we got to pay attention to a, which is right here. Remember, a is the one with the leading coefficient, which is 1, and this number. And then we have to, it has to be different. In that word, it means subtract. When I think of a difference, I think of subtract. So now let's set it up. This is how I always set up difference in squares. When I see something like this and I know I can do it, I do plus and minus. And for the coefficient, I usually just do, if it's perfect squares, like 1, square root of 1 is 1. So I just put x, because that's the, you know, the coefficient was 1, and we just, square root of 1 is 1, so we put 1 and 1 right there. And then it's plus or minus because of the rules, which I'll show you. It'll be better explained once we get the answer. And then, like I said, I like to do square roots because, you know, they're supposed to be perfect square. Maybe at times they're not, but it's okay. But square root of 1 over 4 is 1 over 2. Reason how I got that is square root of 1 is 1 and square root of 4 is 2. So we get this, and this will give us our it will give us this question again once we do the math. And just to check it out, you get to see that if you get this times this and then these two multiply each other, it'd be x over 2 minus x over 2, which is 0. X times x is x squared. A positive 1/2 times a negative 1/2 is negative 1 over 4. That's the difference in square. Just a little memory for us. Okay. And now we can do one where we have an a, which, like I said, is the same thing. Let's start with the process. So we do plus, then minus, and then I like to do square. The square root of 4 is 2, so I get 2x. Square root of 9 is 3. Something, you know, I know this is going really fast, but like I said, it's review. You know, and just to check it out, 3 times 2 is 6x. 2x times negative 3 is negative 6x. Those will cancel each other out. 3 times negative 3 is negative 9. 2x times 2x is 4x. So it answers out. Now, there's something I do want you to do for me. Just, you know, quick recap. Something that will probably jog your mind and drive you crazy. But can you do the factoring with perfect square with this? I'll give you time to do it, and once we get back to the video, I'll go over your answer. Now that we've done it together, or you did it by yourself, let's do it together. Because I know my class is very smart. We probably all got this. So you'll just do what I did. You know the difference, so it's just 2. You know it's plus or minus. And then square root of a squared is a. And then the square root of b squared is b. I know it's fairly simple. And then, you know, it checks out. So let's, you know, I'll actually write it all out for you. So a times a is a squared. A times negative b is negative ab. B times a is positive ab. Then b times b is negative b squared. These will cancel. And then you get a squared minus b squared. Simple and clean, you know what I mean? That's good. So this is just something that we were trying to go over, just to give you some sense of idea on factoring, because I know we've done this before. Probably just either been a while or something you haven't thought about. And now let's go over factoring by grouping. Not sure how long it's been since you've done this one, but how I like to start off is I like to group them first. So I'll just take these 2 right here, and then take these 2 right here, and then we start grouping them. So let's do that. So the thing I can factor out of x cubed minus 2x squared is x squared. And then once I get that, I would be left with x minus 2. Now let's do the other side. Plus, the only thing I can factor out from 4x minus 8 is 4. Once I factor out the 4, it'll just leave me with x minus 2. And then now we get to take out the like terms. Not take out completely, but you'll see what I mean. So I get the factor these out. It's like taking out the like terms like we did here, x and x squared. So since they all share the x squared here, we are left with, so let's take out x squared, or x, not x squared, why do I keep saying x squared, x minus 2, and then we're left with times x squared plus 4. And then that's it. And if you do it again, you know, just to make sure, x times x squared is x cubed, x times 4 is plus 4x, x times, or negative 2 times x squared is minus 2x squared, and then negative 2 times 4 is negative 8. And you see, I mean, even though they're out of order, see x cubed, negative 2x squared, negative 2x squared, 4x, minus 8. So it all works out in the end. It's just something for you to note, because, you know, this is review. But like I said, I don't expect everyone to remember this, so that's why we're going over factoring. Now let's go over this one, but there is something I want you to do for me. Please name the leading coefficient of this polynomial, just so we have an understanding of what the leading coefficient is. I'll give you some times, and once we get back, I'll tell you the answer, see if you're correct or not. So the correct answer, so first off, I would just like to show the leading coefficient is the one with the highest degree. Right here, 4 is bigger than 3, 2, and 1. So, and the coefficient is, you could say, well, there's nothing there, but remember, there's an invisible 1. So the leading coefficient is 1. If you got that, give yourself a pat on the back. If not, it's fine. We're still learning. And that's just a terminology that I would expect you to learn. And if not, it's okay. We're recapping and reviewing. So just remember that term, leading coefficient. Now we do that. You're like, how do we do the grouping? Well, first off, I would like to already factor something out. They all have something in common. So there's an x to the 4, x to the 3, x squared, and x. And I'm like, that's too many x for me. So I'm gonna do x, factor out the x, now you get x3 minus 3x squared plus x minus 3. Whew. Now we can do the grouping. Yeah, I know you're like, Mr. Nguyen, you're kind of funny. Yes, I am pretty funny. So now that we did that, I'm gonna write out the x out here, parentheses. So the thing that they share in common here is x squared. And then there'll be x minus 3, then plus. But you're like, you can't really factor anything out. Technically you can, because what we're trying to do is trying to have the same number. Something I should have said in the first one, but there's a reason why we do this. X minus 3, because we want to be able to factor out something common, which is right here. So these has to be the same in here, the parentheses, in order, in order for you to be able to use this, it has to be like the same when you group them. If it's not, then maybe this method doesn't work, because there's a condition that has to be met for using the grouping method, which when you do the factoring, the grouping factoring, the end result has to have something similar, so you could factor it out. And then in the end, after we do all that, we get x parentheses, I'm gonna factor that out, x minus 3, and then x squared plus 1. Ooh, I should have sorry, should have been moving it up. Sorry about that. So something I did, like I said, because I apologize, I factored out the x squared because those right here. Then after that, I said that there was nothing in common, but we know that we can factor out the 1, because 1 times x is x. 1 times 3 is, or negative 3 is negative 3, and what we're looking for was the the same inside the parentheses, which is x minus 3, x minus 3. After we get that, we can factor it out of the equation and put it out here, and then we're left with x squared plus 1 inside the parentheses. Get it? Got it? Good. Okay. Final thing that we're gonna do. First off, I know something maybe you haven't heard of in a while, but we're gonna do completing the squares. And you're gonna ask why we do that. Well, there's like questions, like, you know, let's go back to the beginning. It's the same thing as why do we factor? Because this helps us find some zeros within our polynomial. Like if we're looking for the zeros, what we do here, you know, we just do x minus 1 equals 0. And then we put 1 on to the other side, plus 1, plus 1. Then we get x equals 1. And we could do the same thing for here. But, you know, x plus 4 equals 0. X equals -4. And that's how we find our zeros when we do the factoring. So that's just something important to note. And that will lead us to why we do completing the square. Completing the square is also a way to find some zeros, if there are any existing zeros. And you know, and I wrote down rules for you. So we're gonna go over some of the rules, but you could pause the video if you want to write down the rules. It's something I think you remember, you know, maybe not. But if you have not, please pause the video while I am trying to go over this, because I'm gonna move pretty fast, because, you know, I'm Sonic the Hedgehog, you know. Anywho, or the Flash, you know, whatever you guys want to call me. So step 1, or this is my version of the, you know, completing a square steps. Step 1 is divide all terms by a. What I mean by a is whatever this value is. If it's 1, you don't have to divide it, but, you know, just keep in mind that, I mean, because if you divide anything by 1, is the whatever the number is. So, and then look, leading coefficient, because a is our leading coefficient, because the degree of the x value in a for that coefficient is the highest degree, because it's a quadratic function, and quadratic is x squared. It should be the highest, unless you could argue and then find me a lawyer to prove that, then, you know, good luck. So anywho, step 1, divide all terms by a. Step 2, move the number term or the constant. I say c divided by a. So let's say a was 4 or 1. C was 4. 4 divided by 1 is still 4. We move it to the other side. And when you do that, it should be a negative. You know, that's how we move it to the other side. But just, you know, just keep that in mind. I'm just giving you a step by step. I wasn't really too explicit on what happens when that happens, but we're gonna go over some examples, so don't worry. And then the next step is to complete the square on the left side by getting your b divided by a value and divide it by 2. Then square your result like this, which I put right here. So b divided by 2a squared, and then you add whatever you do on one side, you do on the other. So if you have this on the left side, then it has to be all on the right side also. That will make more sense once we go over some example, but for now, just remember that. Step 4, take the square root on both sides of the equation after you convert the left side into this. So because the whole point of doing the completing the square is to end up having your equation like this. This q is just whatever ends up, like, so what if you have c over a plus that term here, this just ends up being q. It's a placeholder. Don't worry if this is confusing for now. Just wait until we do some examples, and that will make more sense. And then lastly, subtract the number that remains on the left side to the equation and move it to the right side of the equation to isolate and solve for x. That is the last step, and we will be doing some examples, so don't worry if none of this makes sense. Please pause the video if you need to write some of the notes down. If you don't feel like you need these notes because you remember all these steps already, then feel free to not pause and continue. But if you do need to write notes, here's the time. Just pause it and, you know, play it whenever you're done writing down your notes. If not, I'm gonna move on. So here is an example. See, you see factoring doesn't work, and you're like, oh man, I mean, you can try it, but it's 1 times 1, 1 times 1, 1 plus 1 is 2, and you know, you can never get to the 4. So first up, I would do divide by a, but I see a is 1, So you can skip that step if you want, but if you like to go step by step, then you could divide by 1. But you also give you this, so it doesn't matter. Now I said move C to the other side. So I do that. So it's x squared plus 4x equals -1. Now we get this b term, and we do that. So it would be, let's see, it would be 4 divided by 2 squared. So 4 divided by 2 is 2. Squared is 4. So we still get, 4. So it'll be x squared plus 4x plus 4 equals -1 plus 4. Now we can add this together. It'll just be 3. Good enough. Now we can do you remember the step that had that x plus p squared? So we know that this is just x plus 2 squared, because this is the same thing as x plus 2 times x plus 2. We know that. So it would be x squared. 2x plus 2x is 4x, and then 2 times 2 is 4. That's the whole reason why we do this right here, so we can have something as perfect as this square. So now that we got that, let me move down so we can do this. Move down. X plus 2 squared equals 3. After we do that, we have to square both sides. And then I get x plus 2, the square root and the square cancel, and you get plus or minus square root of 3. You can use a calculator if you want, or you can leave it like this. And then after that, the last step, minus 2, and then we get that x is in the end -2. Sorry, right there. Plus or minus square root of 3. And if you want to calculate it, you would first do -2 plus square root of 3, and then you do -2 minus square root of 3, and you get you should get 2 results. So let me just write it down so you don't forget. It will be -2 plus square root of 3 and -2 minus square root of 3. And then in the end, I want you to do this one by yourself, please, and we'll go over it in the next class. Thank you for your time, and I hope you enjoy your day.